Welcome back to the AWS Solution Architect Associate series. In today's session, we continue the domain 2, that is design resilient architectures, and our focus is on how to design the highly available and fault tolerant architecture on AWS. This is one of the most critical skills for any cloud architect because almost every real world system must run reliably, even during failures. Whether that's an availability zone outage, or the region level disruption, or the network issues, or whether the application crashes. We will explore failover strategies, distributed system concepts, disaster recovery, global infrastructure, and load balancing replications, and also how to avoid the single points of failure using AWS managed cloud native services. Let's get started. Before designing resilient architectures, it's important to understand the difference between high availability and fault tolerance. High availability means your workload stays reachable with minimal downtime, even if parts of the systems fail. This typically involves redundancy across availability zones. Fault tolerance goes a step further. The system keeps operating system even during component or infrastructure failures, often without any noticeable disruption. Achieving this requires designing systems that eliminate all single points of failure, replicate resources across multiple zones or regions, or detect issues automatically. In AWS, these concepts are made easier thanks to the multi AZ services, managed databases, load balancers, and automated failover. AWS resilience begins with its global infrastructure. Regions are isolated geographies designed for fault isolation. Each region contains multiple availability zones, separated by miles and connected with low latency, high bandwidth links. Global services like IAM or CloudFront operate beyond regions, while most compute, storage, and database services are regional. Understanding which services are regional versus which are global determines how you distribute your application to meet the uptime, compliance, and recovery needs. Distributed design patterns helps ensure workloads survive infrastructure failures. In an active-active setup, traffic flows across multiple availability zones simultaneously, which is common for load balance applications. In an active passive standby environment, which is kept warm and hot and activated during failover. For global customers, multi-region architectures are used to ensure resilience even if an entire region is impacted. Decoupling workloads with queues, event buses, and microservices helps limit the blast radius and ensures the component fail independently rather than dragging down the entire system. Load balancing is central to high availability. The application of load balancer, the application load balancer basically is used for HTTP and HTTPS traffic and supports the intelligent routing. The network load balancer is preferred and it's millions of connections per second. The network load balancer is preferred for ultra low latency and millions of connections per second. Global Accelerator helps route the global users to the nearest healthy endpoint and the AWS global network infrastructure. By enabling cross-zone load balancing, you ensure that if one availability zone fails, traffic is redirected to the seamlessly to healthy instances in other zones, which keeps your application online without manual intervention. Failover is how a system redirects during a failure. AWS provides several automated failover mechanisms using health checks at the load balancer and the service or the DNS level. With Route 53 health checks, you can shift the traffic between active and the standby environment based on the health check or the latency. Active-active failover distributes the traffic to multiple healthy endpoints at all times, while active-passive keeps the standby ready. These strategic helps basically achieve the continuous operations even during unexpected disruptions. Disaster recovery planning ensures the business continuity in the event of major failures. AWS categorizes the disaster recovery strategies into four levels. The first one is backup and restore, which is lowest cost and highest RTO recovery time objective. Second is pilot light, which is minimal infrastructure, which keeps it ready to scale quickly. Third one is warm standby, which is scaling down live environment that increase your capacity fast. And the fourth one is active both regions, which in which both the regions simultaneously operate with near zero downtime and RTO. As a solution architect, you must choose a disaster recovery strategy based on the business needs, cost, and the acceptable downtime. Storage plays a huge role in resilience. Amazon S3 provides 11 nines of durability by replicating the objects across multiple facilities within a region. EBS snapshots replicate the data to S3 for long-term durability. With RDS Multi AZ, AWS maintains a synchronous standby replica that automatically takes over if the primary fails. For global low latency access and multi-region resilience, this DynamoDB Global Tables replicate the data across multiple regions with built-in conflict resolution. One effective strategy for high availability is using the fully managed AWS services. This AWS Lambda scales automatically across availability zones. SQS helps decouple the system's components, preventing the cascading failures. DynamoDB is multi-AZ by default and offers global replication. RDS Proxy improves the reliability by pooling the connections and helping legacy applications survive the failovers. Managed services reduce the operational burden and eliminate many failure scenarios common in self-managed systems. Resilient architectures require full visibility into application and infrastructure health. CloudWatch provides alarms, metrics, and dashboards that help the detect anomalies earlier. AWS X-Ray offers the distributed tracing that shows how request flows across microservices and helps identify bottlenecks. Logs from ALB, Lambda, VPC flows, and CloudTrail combine to give a 360-degree view. These monitoring tools trigger auto health mechanism like auto scaling, lambda functions, or the event driven replacement to maintain the availability. Immutable infrastructure means you never modify the servers or the environments directly. Instead, you replace them with a new version. This reduces the configuration drift and prevents the issues caused by manual changes. Blue-green deployment allows the traffic to switch seamlessly between versions. Using versioned AMIs, Lambda functions, or the container images ensures the predictable and consistent deployment with instant rolling back options, which is a key requirement for fault-tolerant systems. So to summarize, in this video we explored how to design the highly available and fault-tolerant architecture using the AWS best practices. We looked at AWS global infrastructure, failover patterns, multi-AZ replications, disaster recovery strategies, load balancing, managed services, and monitoring tools that improve the reliability. These concepts are essential for passing the SAA C03 exam and for building real-world resilient workloads on AWS. In the next video, we begin domain 3, that is designing the high performing architectures, starting with this determining the high performing and scalable storage solutions. We will explore S3, EFS, EBS, hybrid storage, performance tuning, and choosing the storage options that scale with your workloads. If you are enjoying this series, don't forget to like, subscribe, and share. See you in the next session. Thank you.